Hope you had a wonderful holiday. The first point of interest is the folio. So today's a checkpoint, so I want to see what you've done. If you haven't got it here, there's a place for you to upload it tonight. So I'll come around after we've done our teaching and have a look at that. What you're going to find with this unit is there's a number of exercises, but they're quite short. And so when we get to weeks 2 and 3, you'll find we spend the first half of the lesson finishing the exercise, and then the second half of the lesson to work on the folio. So checkpoint for folio today. The draft for that will be Friday of week 3, and the final topic for that's Friday of week 5. I've mapped this unit out on sector, and if you look at it, we've got the test scheduled about the end of week 6. So that's pretty well when I've finished in the past. Okay, week 6, week 7 is a bit of wiggle room there. All right, let's get into it. So chapter 8, chapter 8A and B is going to be some new theory, but then when we go back at chapter 8, C, D, E, and F, that's all stuff that you have done in year 11. Okay, so 8A and B will be new, C, D, E, F, all stuff we've seen before, and then chapter 9 will be new. So today we're talking about continuous random variables, and it's going to begin with, let's just talk about, well, what are the two types of variables? So discrete variables are variables that you count, okay, things that you count. They have discrete number values, and continuous variables occur over an interval. They're things you measure. So we did discrete variables in chapter 7 when we did our test on binomial distributions, so that's done. So here in chapter 8 and 9, we're focusing on continuous random variables. And so that's commonly associated with the normal distribution. Okay, we've seen that, although we are going to look at other probability density functions. Okay, I've said lots of words. Let's look at the example. We have a continuous random variable x can take any real value within a particular range. 50 eggs are weighed at random, and their weights are shown in the frequency table below. So you can see this table here, I've got some intervals. Notice the first interval from 50 to 55. All right, so it includes 50, but it doesn't include 55. It goes up to 54.999999, but as soon as an egg weighs 55 grams, it's going to be in the next interval. We've also got the relative frequency there, okay? And the relative frequency is just the number we observed in that interval divided by the total number we observed, all right? So that's a probability. Okay, and we can represent it as a graph. Let's jump down right down to the bottom at part A. Find the probability that the weight of a randomly selected egg is between 55 and 65 grams, okay? So if we're going from 55 to 65, all right? Well, that's going to be the interval from 55 to 60 plus the interval from 60 to 65. So the probability of it being between 55 and 60 is 0.26. And the probability of it being between 60 and 65 is 0.4. And so therefore the probability of it being between 55 and 65 is 0.66. All right, so that's exercise 8A. There's a few frequency tables and that kind of thing in these kind of calculations. All right, and we'll just rub that out so we can get to the probability density functions. So a probability density function, this is some new information for us in 8B. It's a function that's going to tell you the probability of things existing over an interval. Classic example is height. Okay, it follows a normal distribution. All right, the mean 175, standard deviation 15. So that's taking down here to 160. That's taking up to 190. All right, and what we notice if we're going to graph this is it exists above the x-axis. Why is that? Probabilities have to be positive. Okay, so that's the first condition for a probability density function, that it has to exist above the x-axis. And the second condition is that the integral from the lower boundary to the upper boundary of the function is 1. What does that mean? The total area under the curve is 1, that all probabilities add up to 1. Okay, so two properties, above the x-axis, sum of probabilities is 1. That's going to make it a valid density function. Okay, let's flick the page over. And so now we're getting into 8B.2. So So we've done 8A, here's 8B.1. And 8B.2, the reason we're doing them together is because 8B.1 introduces you to a probability density function and 8B.2 looks at properties of it. It's useful to just do them both together. Okay, so we've got consider the function f of x equals x on top of a. This is our probability density function. And it's valid over the interval 0 to 4. Okay? It's valid over that interval. Find a given it is a valid probability density function. Okay, so because it's valid, there's two properties. Firstly, it's above the x-axis. Second is the integral from the lower boundary to the upper boundary of the function is equal to 1. Okay, and now with that information we can solve for a. So I'll do that. We're going to have x squared on 2a. Alright, integral of x is x squared on 2, and a is hanging out at the bottom, that's just a number. This is equal to 1. We'll plug the 4 and the 0 in, so we're going to have 4 squared on 2a. Take the 0, and plug the 0 equals 1. We've got 16 is 2a, we have a is 8. Okay. So I'm going to sketch this probability distribution for you guys. Show you what it looks like. So the function is x on top of 8. All right, we figured out the value of a is 8. And so here's what it looks like. All right, if we think about this, this is actually the equation of a line, isn't it? It's 1 on 8 times x. Has a y-intercept of 0, so it passes through the point of origin, and it has positive slope. So it's going to look like that. Okay? And we can graph it on our calculator to observe that. And what this shows you is the probability of certain events occurring. Okay? So we can see, well, firstly we've established that the whole area under the curve adds up to 1. Okay, that's because all probable events adds to 1. Looking at this, who can tell me what's the most likely event? 4. The probability is highest here. Okay, so that's going to be the most likely event, and the least likely would be 0. Okay, it has a probability of 0. All right, so let's go through and answer some properties about it. So we're going to use the box above. Part B, find the mean, median, and mode. Now, firstly, we might do the mode. Okay, what does it say? The mode is the event which maximizes the function. So the mode is the event on the x-axis, which gives you the highest value of y. That's going to be here. That's the highest value of y, so the mode is 4. Okay, for the median. Let's think about the median. The median is not going to be 2. All right, there's a temptation to say median's halfway through the data set, it's 2. Now the median occurs between 50% of the data set. So we've got 50% there and 50% there. So it's actually going to be a bit further along than 2, isn't it, to make sure it's balanced either side. So this is going to be the median here. Okay, the formula for the median, always the case, is it's the integral from 0 to m, not from 0, from the lower boundary to the middle, m is the median, of the function being equal to half. All right, all this is saying is it's when the probability from the lower boundary to the middle equals half. All right, we've got half the probability on the left, half the probability on the right. Okay, so let's process that one. That's going to be x squared on 16 from 0 to n equals half. We will have m squared on 16 equals half. We'll have m squared is 8. We'll have n is the square root of 8. So the value of the median then is the square root of 8. And you could write plus minus 8, right? But technically it's positive 8 because it has to exist, positive root 8, because it has to exist between 0 and 4. Okay, so that's the median. All right. Next, the mean. So the formula for the mean, I'll write up the formula here. X f of x. Alright, so some people miss that, it's x times f of x. So in our circumstance, 0 to 4 of x times x on 8. Alright. And now with these ones, because it's not a test on integration, we can just crunch them in our calculator. Only if it says using fundamental theorem of calculus would you be required to use integration techniques. So let's do that from 0 to 4, x squared on 8, I've got 8 on 3. Alright, so the mean of the distribution, what's that, 2.6 recurring. The mode is 4, that's the most frequent. And the median, the halfway point for the data set, is the square root of 8. Okay, part C, find the variance and standard deviation. So firstly, we're going to find the variance, because the standard deviation is the square root of the variance. So we use the formula there, and you can use either. There are two formulas. I'm going to opt to use the one on the left. So if we do from A to B of x squared f of x, with regards to x, take the mean square. So in our circumstance, 0 to 4, x squared times x on 8. Okay, it's really important to note the position of the dx. Okay, why is that? Because that tells you it's the end of the integral. This is what you're integrating, and then you, after that, you're going to subtract 8 on 3 squared. So I'll process that quickly. From 0 to 4, I've got 8 on 9, the value relates to, which means the standard deviation is going to be the square root of 8 on 3. Okay, being the square root of the variance. And last one, part D, find the probability of the event that takes place between 1 and 2. Alright, so that's going to be the area under the curve from 1 to 2 of the function. So what's that going to be? 3 and 16. Okay, so that's enough to get us started. 8A, 8B.1 and 8B.2. So in 8A, we'll find some pretty basic probability calculations involving tables. In 8B.1, they're going to introduce you to these density functions, and then in 8B.2, you use the properties of the functions. So that's all today.